This video is the first in a series about programming using the Python language. As you probably know, in any text-based programming language, the code commands are contained in a simple text-formatted computer file called the source code. Although Python programming language needs an interpreter to execute its source code, in actuality Python's execution model is quite sophisticated and uses a hybrid mode. That of a compiler, combined with an interpreter for the final execution of its source code. So, when you run Python code, it first gets compiled into an intermediate tokenized code form known as bytecode, and then, the Python virtual machine, PVM, does the final execution of this bytecode. So, Python uses a two-step process: compilation to bytecode and interpretation by the PVM. Here's how it works. First step is compilation to bytecode. Python's compiler translates the source code, py files, into bytecode, .pyc files. This bytecode is a low-level, platform-independent representation of the source code. Second step is bytecode interpretation. The PVM reads the bytecode, translates it to machine code, and sends it to the CPU to be finally executed. Python's execution model differs from both compiled and interpreted languages, as follows. Interpreted languages like JavaScript often execute code directly without an intermediate bytecode step, leading to slower performance. Compiled languages like C++ translate source code directly into machine code for the target platform, offering faster execution but less portability. Hybrid languages like Java compiles to bytecode like Python, but the Java Virtual Machine, JVM, has different structure and performance characteristics. The conclusion is that Python's use of bytecode and the PVM provides a balance between performance and portability, which highlights Python's efficiency and flexibility. These traits contribute to Python's widespread popularity, distinguishing it from other programming languages.